Hello friends, today we'll learn Star Schema and the Star Schema keys. What is a schema? So, a structure of database design, or it may be a data warehouse design. So, what we have to focus in this topic, how to design a data warehouse, and before this designing, what we have to define, that is the dimensions or the dimension tables and the fact tables. You have seen the databases, how to design the database, that you use entity relationship data model. So it is the commonly used design for the relational databases where the database schema consists of the set of entities and relationships between the entities. And this kind of model is suitable for OLTP, that is online transaction processing. But this schema is not helpful at the data warehouse design. So the data warehouse design requires a concise, subject-oriented schema which will facilitate the online data analysis. So the most popular data model for a data warehouse is a multidimensional model. Such a model can exist in the form of a star schema, snowflake schema, or fact constellation. This model views data in the form of data cube. Let's learn the few key terms related to the schema. First is the dimensions. These are the entities with respect to an organization for which we want to keep the records. The famous example given is all electronics. It may create a sales data warehouse in order to keep records of store sales. So what will be the dimensions for the all electronics related to the sales? These are the time, the items, branch, and the location. This may have the different branches and located at the different areas. So these are called as the dimensions. So each dimension have a table associated with it and it is called as a dimension table. So this is a very important term for designing the data warehouse or schema, that is the dimension table. The another key term is the fact or fact tables. These are the numerical measures. It consists of the facts and the keys. For example, for the all electronics, the number of items sold can be a numerical measure, or the dollars sold, the total bill amount. So all these are the numerical measures and these are called as the facts. So in multidimensional data model is organized around a central theme which is known as a fact table. Facts can be think of as quantities by which we want to analyze the relationship between dimensions. The fact table contains the names of the facts or measures as well as keys to each of the related dimension tables. So all the primary keys of the dimensions tables are included in the fact table that we'll see in detail in the upcoming videos. There are different types of measures: distributive, if the result is obtained by applying an aggregate function on number of values, say n, is same as that obtained by applying the function on all the data without partitioning. Distributive. For example, count of. Let's say you have to count the 100. Count for 100 records. Then count of 100. Sum, min, max. These are the distributive measures. The second type of measure is algebraic. Algebraic function can be computed by the algebraic function. Can you list out some aggregate functions? Average. Yes, you have calculated average, right? So, each is obtained by distributive aggregate function. So, average is equal to sum divided by the total number of values. For example, you have the 5 subjects, and for each subject out of 100 marks is given. So how you will calculate your aggregate marks? You will sum up all the marks of 5 subjects, divide by 5, that is the total number of subjects. In this case, we are using two distributive functions, sum and count, and we are calculating the third, that is the average. So this is the algebraic measure. Another are mean over n and standard deviation. A measure is algebraic if it is obtained by applying an algebraic aggregate function. And the third type of measure is holistic. If there is no constant bound on the storage side, then we can call it as a holistic. A measure is holistic if it is obtained by applying a holistic aggregate function. For example, median, mode, rank. There does not exist an algebraic function with m arguments. An aggregate function is holistic if there is no constant bound on the storage size needed to describe a sub-aggregate. So these are the three types of measures used in the fact tables. Now let's see the star schema. The number of dimension tables are connected to a central fact table, emerging out a star-like structure. So the name is given as star schema. You can see this structure, it is a star. So there are 4-dimension tables connected to a central fact table. Star schema. The star schema or the schema diagram looks like a star burst with the dimension tables connected in a radial pattern with the central fact table. So here we have a data warehouse contains a last central table known as a fact table containing the bulk of data and which is with no redundancy. So again, a set of smaller attendant tables known as the dimension tables, one for each dimension. So each dimension is represented by only one table and each table contains a set of attributes. For example, you can see in this, it is all electronics example. The central fact table is cells table. The dimension tables are time, branch, item, and the location. Each dimension table is having its time key, item key, location key, and branch key as the primary keys. Along with they have their different attributes, and each dimension table is connected to the central fact table. Fact table contains the measures dollars sold and units sold. Branch, branch key, branch name, branch type. These are the attributes of branch dimension. For the item dimension, we have item key, item name, branch type, and the supplier type. So there is a central sales fact table with the foreign keys, the primary keys of the dimensions added as a foreign keys. Let's see it in detail. So the another topic is star schema keys. So each dimension table has a primary key. All the keys of dimension tables are associated with fact table. So the relationship between the dimension table and the fact table is built by the keys. The primary keys of dimension tables are used as foreign keys. Fact table is called as referencing table. It consists of foreign key references to dimension tables. The dimension table is called reference table. It has a primary key, which is a foreign key reference to the fact table. The fact table primary key is one or combination of the foreign keys. So all the primary keys exported in the imported in the fact table and collectively act as a primary key of itself. Let's explain with the help of diagram. So in this case, the time, branch, item and location, these are the dimensions. The primary keys of these dimensions are time key, branch key, item key, location key respectively. All these primary keys are given in the fact table and collectively all these acts as a primary key for the sales fact table. So basically these are the foreign keys importing the values from the base or dimension tables. Along with the keys, the fact table consists of measures. It has a unit sold and the dollar sold. As the time key in the sales fact table is the foreign key, so the values available in the main dimension table should be only those values can be accessible for the sales fact table, and similarly for all other keys. So these are the star schema keys. The reference. So in today's lecture we have studied the star schema design as well as we have focused on the star schema